Okay, in lesson 22, we're looking at uniform motion problems with equal distances and similar triangles and proportions. So in our first example, we are looking at a uniform motion problem. Roger made the trip on Sunday and Judy made the trip on Monday. Roger traveled at 12 miles per hour and Judy traveled at 20 miles per hour. So her time was 2 hours less than Roger's time. How far did they travel? So they're each going to have a rate, time, and distance. We're going to have the rate of Judy, and then we're going to have the rate of Roger. Oh, the rate, time, and distance of Roger. So Judy's rate was 20 miles per hour. Roger's was 12 miles per hour. Okay, and then their time, it says Judy's time was 2 hours less than Roger's, so if Roger's is t, Judy's time will be t minus 2. And then distance is rate times time, so the distance for Judy is 20 times t minus 2, and the distance for Roger is 12 times t. Now because this is the same trip, they are the same distance, so we just need to set them equal to each other. So 20 times t minus 2 equals 12t. I would distribute 20t minus 40 equals 12t, then subtract 20t on both sides. So negative 40 equals a negative 8t, and divide both sides by negative 8. So the time is 5, but it asks how far did they travel. So I'm going to take that 5 and put it in place of this time. You could use either one and get the same answer, but I think the Rogers distance formula is a little bit easier. So I'm going to say 12 times 5 equals 60. So their distance is 60 miles. Alright, the next example is another uniform motion problem with equal distances. Briar Rabbit hopped off towards the briar patch at 10 kilometers per hour at 10 a.m. At noon, Brer Wolf began the chase from the same starting point. If he caught Brer Rabbit at 2 p.m., how fast did he run? So we have a rate, time, and distance for the rabbit, and a rate, time, and distance for the wolf. Okay, the rate of the rabbit was 10 kilometers per hour, and its time from 10 a.m. to 2 p.m. is 4 hours, and its distance is rate times time, so 10 times 4. Now for the wolf, we don't know the wolf's rate, so I'm just going to say that's R. The wolf's time is 2, because he started at noon, and noon to 2 p.m. is 2 hours. And then the distance for the wolf is rate times time, so I'm just going to say 2R. And these distances are the same, because it says the wolf began the chase from the same starting point. So I'm going to set these equal to each other to solve for the rate of the wolf. So 10 times 4 equals 2 times R, and I'll multiply the 10 times the 4, 40 equals 2R, and divide both sides by 2. So my rate is 20, and this was in kilometers per hour. And that is what our problem was looking for, because it says how fast did he run. Alright, our last example, we're looking at similar triangles. It says solve for the missing sides by using ratios themselves. When the ratios are connected with the equal signs, they are proportions. So we see that 5 is related to 5 is related to x, and 7 is related to 9, and 8 is related to y. because they're in between the same angles on the different triangles. So to solve for x, I would say x over 5 equals 9 over 7. So I've kept the big triangle on top and little triangle numbers on bottom. You want to just keep them in that same order. Then I would just multiply both sides by 5. So x equals 45 over 7. And then we need to find out what y equals. So this time I'll put y over 8 equals that same ratio, 9 over 7. Then I'll multiply both sides by 8. So y equals 72 over 7. And those are our two missing side lengths.